All right, welcome to the office hour tonight. Let's jump right in. So, take a look at number one. We're using two identical right triangular templates. We've got one that is ABC and one that's DEF. Angle B is 90 degrees. So I'm going to put that here. So we have ABC, and then we're going to make DEF. And the measure of angle B is 90, and the measure of angle A is 34. So this is 34, which means this is 34. And what is the measure of angle F? Well, now that we've got it set up this way, F is just, these add up to 180, but in a right triangle, the other two angles just add up to 90. So this angle is just going to be whatever 90 minus 34 is, which is 56. All right, on to number two. So they give us the DCA, and all right, these are already labeled for us, so we don't really have to read it. We just need to find the value of X. Um, oh, and my bad. CD is equal to CA. So this side is congruent to this side. All right. Well, then that was what we're going to use first. So that means that tells me basically what I've outlined in blue is an isosceles triangle. So these two base angles are congruent. And what I'm going to do is I'm just going to do 180 minus 54. That'll tell me what these two angles add up to, and then just divide that by 2. So 180 minus 54 is 126 divided by 2. These each need to be 63. Then what I'm going to do is notice, so let me change colors here so you can really see this. What I have is this triangle, whoops, that I'm trying to outline in red. Um, X is what's called an exterior angle on that. So I'm just going to use the exterior angle theorem to do the minimal amount of work. And the exterior angle theorem says this: an exterior angle is equal to the sum of the two opposite interior angles of that triangle. So X is simply just going to be 63 plus 32, which is 95. All right, so 95 is our final answer. If you don't know the exterior angle theorem, it's no big deal because just use the 32 and 63 to find this angle, and then you'll just do 180 minus that to get x. So it'd be an extra step, but you can certainly still get it. All right, on to number three. So in right triangle RST, the measure of S is 90 degrees. All right, so we've just got a single right triangle here, and S is the 90. So I'm just going to make it RST like that. And the cosine of R, so that is the adjacent over the hypotenuse is root 15 over 8. But before I waste my time finding the side, they asked me for the sine of t. Well, sine is opposite over hypotenuse. Um, I think I just skipped over that. Cosine is adjacent over hypotenuse, so that's why I labeled the adjacent to r root 15 and the hypotenuse 8. But now if I want the sine of t, the opposite is also root 15. So root 15 over 8 is the value of sine t. Now, there is a shortcut here. Whenever you have two angles that are complementary, and a situation where you would have that is the two angles, the two non-right angles in a right triangle are going to be complementary. Whenever you have the cosine of one, that'll always equal the sine of the other. And you can kind of see why that is because the opposite and the adjacent flip when you go to the other angle, and it'll be the same side. All right. So if we realized that in the very beginning, we could have known that the answer was exactly the same without drawing a right triangle, which would have been quicker. But I wanted to go over that. Or if you didn't see that, then drawing a right triangle is going to be the way to go. Or there are problems where you do need to draw a right triangle and find the third side and so forth, but not in this one. All right. On to number four. So we have x is 11n minus 47 and z is 7n plus 9. What's the value of y? So what we want to know first is that x and z are congruent. They are called corresponding angles. If you don't remember that, when you have a transversal cutting parallel lines, it's going to create eight angles, four of which are going to be obtuse and four of which are going to be acute. Again, that if it's not perpendicular, that would be a special case. But most of the time, you're going to have four acute angles and four obtuse. What you need to know is all four acute angles are congruent to each other, all four obtuse angles are congruent to each other, and each acute and obtuse is going to be supplementary. All right. If you know it on the level of alternate interior corresponding alternate exterior and same side interior, that's wonderful. But the vocabulary is not really on the SAT. You kind of need to just know what to do. So in this case, I just need to know to set these equal to each other because they are congruent. So I'm going to move the 7n over here, move the 47 over here. So n is 14. Now I'm not done. All right, be careful because 14 is right there. Let's not get, confused by that. We want the value of y. So let's find z. Z is 7n plus 9. So 7 times 14 plus 9 is 107. So even though it looks acute, it's really not, but that's still fine. And then what I want is y. Y is going to be a linear pair with that, so it's going to be supplementary. So y equals 180 minus 107, which is 73 degrees. So we get C. All right, so some good distractors there. If you only stop at 14, you get this answer. If you only stop at 107, you get that answer. But the answer is 73. All right, so we've got these two triangles. The length is that, the smaller logo. All right. The fact that they're similar, okay, tells me this. So X, Y, I'm going to try to do this without drawing it because, again, if you can do that, then you can save a little bit of time. So similar triangles, when I'm given three lengths and I want to find a fourth, usually, there's always exceptions, but usually you're just setting up a proportion. So for the first triangle, X, Y, and YZ, I'm just going to write 56 over 168. So what I'm doing is XY is the first two letters, YZ is the second and third letter. So now when I go to LMN, MN is 42. This is really important. That 42, it's the second, third letter, is going to go on the bottom. And LM is the first letter, second letter, which is I put as XY on top. That is our unknown. So I'm going to put X. And then I'm just going to, I could simplify these, but why waste time? Just do it in the calculator. Just cross multiply 56 times 42, and then whatever that is divided by 168, or throw it in the Desmos if you feel like it. But you end up getting X is equal to 14. And that X is LM. All right, so the key here, the proportion is probably most are going to think of that, but I bet people just will put 42 in the top, just following it in order. But pay attention to the lettering. That's extremely important. All right, on to number six. So we have two triangles that are graphed. All right, I am going to just try to sketch this out loosely. So let's say 3, 2 is here. 310 is here and 15.2 is here. So based on that, I can see that I have a right triangle. Um, and this was P, Q, and R. And then if I just grab another one here, um, I have S is here. Okay. And then T is going to be at 3 comma 2 plus 8K. All right. Well, notice that like if K were 1, then this would just be at 10. So it's going to be like, up here somewhere. I don't really want to go too far up, but it'll be some multiple of 8 plus the 2. All right. So that is where T is going to be. And then likewise, R is going to be, or sorry, my bad. U is going to be 3 plus 12K comma 2. So that's just along here somewhere. Again, it's not that important where I put it. Just again, just as long as I realize that that's kind of what's going on. So I just have this like, it's very tricky how they gave it, but I just have this bigger right triangle that shares this point S and P, and then one may go further or shorter, depending on what K is. Um, so if the measure of angle Q is A degrees, all right, what is the measure of angle U? So this is a right angle. If this is A, then this is A because they're similar triangles, which means they're really asking us about the other angle. And what we talked about earlier is that the other two angles of a right triangle are complementary. So if I just want the other angle, it'll just be 90 minus A because 90 degrees is here. So the other two angles have to add up to 90. So if one's A, the other's 90 minus A. So really, these answers don't even make sense. They're either, if they're similar triangles, they're going to be the same, well, similar right triangles. They're going to be the same angle as what they're giving us, or the other one, complementary. So we just need to sketch it out enough to realize that we were talking about like the other angle than the one they're giving us, and not the right angle. Okay. We're going to try to do this without doing any work. So if the post is perpendicular, it just tells us we have a right triangle. And here is the key, actually. It doesn't even matter if it's a right triangle. X plus Y, they're complementary. What I mentioned earlier was if you have complementary angles, the sine of one always equals the cosine of the other. So the answer is just root 13 over 7. It's just like a pretty specific concept that I see show up a lot. The SAT kind of likes this concept. Um, and because it creates the scenario where if you just know that, you get the answer immediately. And if you don't, you spend some time like drawing out the triangle, right? Like you could draw, we had one just like this before. You could draw the triangle and you could say that this angle is X and this is Y. We know they add up to 90, so they're parts of this right triangle. And if the sine of X is root 13 over 7, you have opposite over hypotenuse. Then when you go to find the cosine of Y, now this root 13 just becomes the adjacent. So you just get the same answer. All right, on to number 8. All right, so the reason that this one's tough to kind of explain is because I want to do it from a perspective that you haven't taken like pre-calc or even like a advanced algebra 2 where you're doing the unit circle because it's not a requirement for the SAT. Um, so what the way that I'm going to explain this is again, if you understand the unit circle, you could do this a different way. But what I'm going to do is I'm going to change it to degrees first. So I'm going to replace pi with 180 because pi is 180 degrees. So I get 101 basically times 60. So I get 6,060, which means I'm just going around a bunch of times. So what I'm going to do is divide that by 360, And it says I get 16.8. So I don't really care about the point 0.8. It means I go around 16 full times. So 16 times 360 is 5,760. So if I go around 16 full times, then if I subtract these, then I'm left with 300. This is what I care about. So I went 300 degrees. So what happens, the way angles are measured is you start on the coordinate plane. You start here and you go around. And what happens is 300 degrees is going to be here in the fourth quadrant. And where it intersects the unit circle, this value here is 1. All right. And this right here is pretty much our angle. So the angle that we have left, so if this was 300, what we have left to go to finish a full circle is 60 degrees. So now what I have is a 30, 60, 90. And if I look at the 30, 60, 90 ratios, this is x root 3, and this is 2x. So if 2x is 1, x is a half. If x is a half, then this side is 1 half root 3, which is root 3 over 2. But I'm going down on the coordinate plane, so the y value is going to be negative. So it's going to be negative root 3 over 2. All right. So again, those of you that have more experience with the unit circle just in a pre-calc class, you might be able to get this way more quickly. All right. But I'm trying to do it just using 30, 60, 90s and kind of rotating around the coordinate plane for all those students who have not taken those classes. And that the SAT is not a requirement. So you can figure this out either, using 30, 60, 90s. All right. The key is just figure out how many times around the circle you went, how much is left over, then how much the angle it makes with the x-axis to figure out which special right triangle you're using. And also remembering that this is going down, so that's a negative value. We could have done that from the beginning and just gotten rid of these answers, and then if you didn't have time, you at the very least would be guessing between those two. All right, so just figure out what quadrant it's in. Like I said, there's a way to do it just in radians. I'm not going to go over that because, again, it's not necessary for the SAT. Just think of pi as 180 degrees to use degrees. All right, so let's take a look at this. A decorative. All right, so I'm going to picture this on the coordinate plane. And what I'm going to do, just to make the problem easier, I'm going to pretend h and k are 0, 0. So the circular courtyard is multiplied. All right, a stone pillar is located here. A decorative bench is located at point B. Okay, so let me just kind of set this up. So this tells me that we have a circle where that's the center. So I'm just going to make a circle where the origin is the center. And then point P is at, if these are both 0, then point P is at negative 6 root 11. So that would be left and up. So I'm going to call this point P. A decorative bench is located at point B, also on the boundary, such that PCB is a right angle. So this is C. So I'm going to put B here just so visually it looks. It could be in the third quadrant too, but I'm just going to make it in the first just to make it easier. So I have that. Okay. What is the distance between the stone pillar and the decorative bench? Okay. So that's just this distance. So what I need to do is first realize that these are the same because they're both radii of the same circle. So therefore, I have what's called a 45, 45, 90 triangle. And a 45, 45, 90 triangle works like this. The ratios are x, x, and x root 2. So if I can find x, then this is just x root 2. So the way that I'm going to get x is I am going to look at this right triangle, where this distance is 6. Really, it's negative 6, but I can think of it as positive. I'm going left 6. and this is root 11. So I'm just going to do the Pythagorean theorem to get that. So I'm going to do 6 squared plus root 11 squared equals c squared. So I get 47 equals c squared. So root 47 is equal to c. Okay. Now that's just the x. That's this length and this length. So the distance between them is the hypotenuse of that 45, 45, 90. So I just do root 47 times root 2, which is root 94, and that is answer choice A. It's a pretty hard problem. All right, we got a regular hexagon. The distance to any of its sides, what's the value of K? All right. Just to visualize this, I know you won't be able to do this on the test, but I am going to try to pull up a hexagon just so it looks better. Okay. So we got a little hexagon going on there, and the perimeter, it's regular, so all the sides are the same. So the perimeter is 432. So I'm just going to do 432 divided by 6. I'm going to focus on this down here. So this is 72 inches. And the distance from the center to any of its sides, so I'm going to go here. And if that's the shortest distance, then we're assuming that it's done perpendicularly. That's K root 3. We want to find the value of K. So then I'm going to connect this. So, which means this right here is 36. All right. What we have to realize here is if this exact triangle, if I made that throughout here, there would be 12 of them because two of them would take up one side and there's six sides. So if I have 12 of them, then this angle here, if I put all them going all the way around, all those angles have to add up to 360. So I have 360 divided by 12 is 30. And look what you got. You got a 30, 60, 90. So if you have a 30, 60, 90 triangle, the sides, and this is going to work out quite conveniently, are x, x root 3, and 2x. Well, our side is k root 3, and they just want k, but k is x and x is 36. So the answer to the problem is simply just 36. So a hint for problems in general, if you ever see a hexagon, it's a shape they like. The reason is because a hexagon is always made up of 30, 60, 90s. All right, so you're going to be using the 30, 60, 90 ratios if you see a hexagon problem. So at least that'll help you get started. So you just, and there's specifically 12, 30, 60, 90s, or there's six equilateral triangles that make it up, but equilateral triangles always break down into 30, 60, 90s. So if you ever see hexagons or equilateral triangles, your brain should say, oh, I'm going to be using 30, 60, 90 on this one. All right, on to number 11. All right, the small triangle is congruent to, or sorry, congruent is similar to the big triangle. That 25 is the whole AC. That'll be important in a second. What's the length of AE? All right, this really shouldn't be too difficult. I'm just double checking myself because it seems sometimes it's like too good to be true, right? But that's why they do that. They mess with you. So what I'm going to do is I'm going to set up a proportion. Because again, I mentioned this before. You have three numbers and there's a fourth you're looking for. And if they're similar triangles, you're going to be able to set up a proportion. We just got to be careful. So I'm going to do 12 over 19 for this one. So I'm going from this length to this length. So I chose the shorter length first. So then I got to go AE, but AE is what we're looking for, over the whole thing, AC, and AC is in fact 25. So it should just be that. So what I'm going to do is cross multiply and be careful. Notice the answers, some of them are fractions. So be careful about doing the whole thing and wasting time. So just do 25 times 12, which is 300, equals 19x. And then we're good to go because when we divide by 19, we just get 300 over 19. All right, so always keep an eye out on your answers because even just the act of doing 300 divided by 19 and then that decimal, and then you look for the answer and you're like, oh man, why did I waste that time? Even just that thought is wasting time. All right. So just keep an eye on your answers and see, it kind of help you make decisions. If they were all decimals, then I would have just done the whole thing in my calculator. All right, on to the last one. So we have two similar right triangles, and they're asking us to do trig. Almost every time I've seen a problem like this, there's no need to draw the two triangles. All right. Um, Only draw the triangle with the information that's given. So that's the RST triangle. Now, sometimes they tell you what angle is the right angle, or we just have to make it so that the hypotenuse is the longest. All right, because that is important. So it must be RST like this, or the other way. But RT has to be the longest side. So then ST is 126 and RS is 120. Okay. Now here is the deal. They're asking for the tan of L, so a lot of times we think, oh no, now I need to draw JKL, and no, you don't. In similar triangles, the angles are congruent. So we just need to figure out which one of these angles goes with L. They tell us straight up here, T corresponds to L. So we're really finding the tan of T. If they don't tell you that, then you look at the ordering, and T is the last letter and L is the last letter. So the ordering that they do is extremely important. So that could tell you as well if they're not kind enough to just directly tell us. And tan is opposite over adjacent. Now, if you want, throw it in Desmos or throw it in your TI-84. Throw it in TI-84. That's how I'm doing it. I'm just going to do 120 divided by 126, math enter, enter. It reduces it for you and gives you 20 over 21. Unless you're like, do this like super fast, I think I just don't worry about too much mental math on the SAT. Just like let the calculator, let Desmos kind of do that work for you. Again, not to waste time or make silly mistakes on the time test. All right. So thanks for coming. Again, as always, check us out on TikTok. This will go on YouTube. Then it'll go on TikTok. We have SAT math courses. We have one-on-one tutoring. So call or text or email. All right. So thanks again.